Alright guys, welcome back for part 2 for the volume of triangular prisms now. Now, triangular prisms will also use, oops, I'm moving that. We'll also use the same formula right here, which is area of the base times height. The only difference is that in order to find our area of the base, this time it's going to be a triangle. So we'll have to know that the area of a triangle is half of the base times the height. So the first example says a triangular prism below has a base area of 9 centimeters. So now this is a triangular prism. So like I said before, they are named after their bases. So in this case, my base is a triangle. It is a prism, so I know my volume formula is area of the base times height. So here's my base, it's a triangle. Here's my other base. Remember, they're going to be opposite from one another. They're not going to touch. And the area of that base is actually 9 centimeters. So that's my capital B. And then it says it has a height of 23 centimeters. So remember, we said our height was the line that connects those two bases, which would be 23 centimeters. So that's my height. So in order to find the volume, I'll just plug it into my formula. So area of the base times height. Area of the base is 9. And then my height is 23. So for your volume, you would just do 9 times 23, which in this case would be 207 cubic centimeters, because remember, it's volume. So pretty much almost the same as a rectangular prism. The only difference is that your big B, your area of the base, is a triangle and not a rectangle. So number 2, find the volume of the prism shown below if the height is 3 inches. Now, since we're talking about volume, now they're saying that my height, which connects my two bases, is 3. And the reason that I say that this line right here is my height, it's because this prism right here doesn't tell me what it is, but I know that this rectangle and this rectangle touch, so those can't be my bases. I know that that rectangle and this rectangle touch, so those can't be my bases. So the only thing that can be my base are my triangles, because they're directly opposite from one another and they won't touch. So those are your bases. So your volume formula is area of the base times height. Your base is a triangle, so remember the area of a triangle is half of base length times height. So 12 times 5. Notice that I use these sides because it has that right angle for the area of triangles. And then you have to divide that by 2 because that's the half. So 12 times 5 is 60. 60 divided by 2 is 30. So the area of the base is 30. And then my height, it told me that it was 3. So 30 times 3 would give me a volume of 90 cubic inches for this one. All right. Next one. The figure below has a height of 18 inches and a volume of 864 cubic inches. What is the area of the base of the figure? So this time I'm looking for my capital B, my area of the base. Once again, it doesn't tell me what this figure is, but I know that this rectangle right here would touch the other rectangle on the side and the bottom one. So those can't be my bases because they wouldn't be parallel to one another. So my bases have to be these triangles because they wouldn't touch and they'll be across from each other. They're parallel. So I'm actually looking for the area of this. This would be my big B. So the area, first off, what kind of shape is it? It's a triangle. So I'm looking for the shape for the area of that. I know the volume of my whole prism would be found by using this formula. And it gives me my volume, which is 864. I don't know what my area of the base is, but I do know that my height, is 18 inches. So just like on rectangular prisms, we're working backwards, but I'm looking for the area of the base and not my height. So in order for me to get my area of the base by itself, I'll use inverse operations. So instead of multiplying my area of the base by 18, I'll divide by 18. So you have 864 divided by 18, which gives you 48 for the area of your base. All right. Number 4, a ramp is being constructed with wood and then filled with concrete. How many cubic feet of concrete will be needed to complete the ramp? The cubic feet tells me that I'm looking for volume. Once again, it doesn't tell me what kind of shape it is, but it's kind of just like the shape on the other end. My bases would be these triangles because those will never touch each other. They're parallel from one another. They're directly across from one another. So those are your bases. So this is a triangular prism because it's named after its base, remember? So my volume would be found by using area of the base times height. My area of the base for this triangle would be half base length times height, which is right here. I'm going to use these two where it forms that right angle, which is 1 times 2.5, which is just 2.5. And then you will need to find half of that 2.5. So that 2.5 divided by 2, which in this case is 1 and 25/100ths. And then your height here, it's 2. So 1 and 25/100ths divided by 2, multiplied by 2 in this case would give you 2, let me change that. Would give you 2.5 cubic feet for that one. All right. And then last one, Mr. Hart asked students to find the volume of the triangular prism below. It does tell us what it is. And we're looking for the value of the capital B, which is the area of the base. So we're not really solving here. Now I know my base are triangles because it is a triangular prism. And in order to find the area of that triangle, remember we have to do half of base length times height. And you have to have a right angle. So where we have that right angle is right here. So I'm actually not going to use that 25. I would use the 24 and the 7. And then I take half of that. So in this case, Omar is the correct one. All right, guys, that's triangular prisms. Be on the lookout for the volume of pyramids coming up next. All right.